Hello guys, and welcome back to my video which is based on shearing force and bending moment. Today we'll discuss about the numerical. Okay, how can we find out the reactive forces, how can we find out the shearing force and bending moment, and how can we make diagrams for them. Now let's say we have a beam. There are three upward forces exerting on this horizontal overhanging beam. 10 kilonewton, 24 kilonewton, 15 kilonewton at C, D and E points respectively, and two downward forces are exerting from at point A and B, RA and RB, and the distances are given here. Now we have to find out firstly the reactive forces RA and RB. Okay, so what can we do? Remember, for an equilibrium, if upward forces are exerting, downward forces are exerting, they will nullify their effect, so the summation of forces will be 0. Similarly, for the moments, clockwise direction, anti-clockwise direction, they are exerting simultaneously, then it will also nullify the effect, and that's why we've got the 0 moment as well at a certain point at equilibrium only. Okay, so summation of forces is 0 at equilibrium. That means downward forces taken as negative, upward forces as positive. So RA, RB positive, and these are three downward forces as negative. So this 34, 9. Okay. Now for moments as well, for moment at point A, let's say, is equals to 0, the summation of all the moments. So this is A point. Now the moment of C with respect to A, so this is anti-clockwise direction force, right? Anti-clock minus 10. How can we find out the moments? Force multiply distance. So minus 10 multiply distance from A is 2. Then D with A, so 24. This is clockwise direction. So plus 24. Multiply the distance between A and D is 4. Then from B to A, this is anti-clockwise direction. So minus RB. And the distance is 4 and 3, 7. This E force is in clockwise direction, but the distance is 4, 3, 7, 3, 10 equals 0. So minus 20, 4 4 is 16, 96 minus 7 RB plus 150 equals 0. So 7 RB equals 76. 150, that means 226. So RB we have got as 7 3 is 21, 7 2 is 14, then 20. 7 2 is 14, 7 is 56. If we put this in first equation, we got RA as 49 minus RB. That means 10 minus 8, 2 minus 2, 7, 6. Okay. Now we have got RA and RB as our reactive forces. Now it's time to find out the shearing forces. So let's write here RA is 16.72 and RB is 332.2. Now for shearing forces, how do you remember the sign convention? All the upward forces on the left positive, right? So let's begin. We want to find out the shearing force at point C. So at C, this is the downward force. So at C, I am making a surface. Okay, the surface here. So surface leftward downward force. Left side of the surface downward force is negative. So minus 10 at point A. Let's again make a surface. So at point A, this is C. You have to take all the points of the one side. So this is at the left of the surface, so minus 10, plus this is the left of surface but upwards, so positive RA. RA means 16.72. So it will be 6.72. Then at point D, if you see at point D, you have to make another thing. So this, take all the points. This is minus 10 plus this is 16.72. Now this is the left side downward force, negative. So minus 34, 16.72. 17.28, right? Thereafter, at point B, draw another line. So at point B, all the negative forces. So this is 10, I is 16.72. This is minus 24, and RB is left side upwards. RB is 32.28. That means it just sums up to be, let's see where it goes. Mm-hmm. 15. Let's do it. This is so 16.72, 32.28, 16.72, 10, 49 minus 34. So 15. That's right. Okay. Now at E, this is the only force, which is 15 kilonewton. So 15, and every point is taken because there is no surface beyond it. So it will be just 15. Okay. Have you got it? Kilonewton. Okay. Because there is no surface, so we have to take this. Now this is the, what is it? We have to make another thing, which is the bending moment. Let's see.